Okay, hello everyone and welcome. Following part is going to be a bit cringe, so I would ask you all to have a seat and fasten your seatbelts. Ladies and gentlemen, this is your captain speaking. Soon we are going to reach the altitude of scaling heights. Thank you for traveling with Next.js. Okay, now let's get this back to reality. Let's land this thing. That's the last one, I promise. My name is Nemanja, and today I'm going to be your guide or captain through this exploration into scalable web architectures. During my career, I had a unique opportunity to work in and live in both Switzerland and Germany, and now I'm located in Belgrade, Serbia, working as a front-end lead engineer, mostly with React and Next.js. Now, we're going to dive deep into how Next.js can help you transform your projects and enhance your scalability. But before that, I'm soon going to be 4 years working at Interventure, a nearshoring company that's headquartered in Zurich, Switzerland, with engineering hubs in both Romania and Serbia. During the last 12 years, they built more than 40 engineering teams for the clients from Germany, Switzerland, USA, and UK. I'm currently working closely with one of the company's clients located in Zurich, Switzerland, called New Wind. So if you're on the lookout for talented, dedicated developers, I'm your go-to guy, so feel free to reach out. Okay, and now let's jump for a bit into some really boring theory stuff that we need to go through. You can see the team also switched from light to dark. We will first go through web design principles for scalable architectures, but from a front-end perspective. Then we are going to see how Next.js tries to achieve these principles, but no worries, I will not bother you for too long with the stuff that you can actually read from the documentation. Main focus of this session is going to be to showcase you how we actually did it in our application and how we achieved highly scalable states. So, onto it. Let's start with modularity. So, the scalable architecture is built around the concept of modularity. You have the system that you break down into smaller independent components, and having this makes it much easier to understand, to develop, and to test the actual system. Next.js, like React-based framework, of course, promotes component-based architecture. And with this approach, it allows you to have reusable independent modules that, when pieced together, can create a really highly complex interfaces. Components can have their own logic and state, but they can also be purely functional, depending on what you pass down as props to them. Next.js also uses the file-based routing, which means that every single file that you placed in the pages directory is going to correspond to a route inside your application. If you decide to place a file into Pages API directory, that file immediately becomes an endpoint. And now, why is this approach cool? Because it allows you to handle your backend logic inside the same project structure, and in this way kind of promotes that cohesive and modular approach of handling both backend and frontend in unified manner. Next.js, of course, supports CSS modules, which allows you to localize your styles to an independent component. And in this way, it also promotes modularity in styling because it doesn't allow conflicts between the styles from other parts of the application. There is also support for dynamic imports with Webpack included, where you can load your modules and components when they're needed. And of course, last but not the least, there is middleware, which allows you to run code before the request is done. So imagine receiving a request. You can then rewrite it, redirect it, modify headers in both request and response, or you can just directly respond to the client. And the important thing to note is that middleware runs before cache content and before routes are matched. The second design principle is definitely rendering. And when it comes to rendering, you have different options. You can opt in for client side, server side, or have a hybrid approach. The goal at the end is basically the same: reduce the load on the client side. And with this, you're going to improve performance, you're going to improve your UX, and also SEO. If you have the opportunity when you're in the design phase of your application to see and to decide which parts of the application are not going to be that dynamic and where there's an opportunity to use something like SSG, like static site generation or server-side rendering, or even a hybrid approach, do it. It's going to be worth afterwards. Next.js supports SSG and SSR. Now let's see what is the difference between two of those. So with static site generation, on a request, during the build time, basically you have all of your data fetched and the page is generated, then that HTML is sent to the client on every single request. While we have the server-side rendering, where on every single request, data is being fetched again, and you're going to receive a different HTML. We also have an ISR as a hybrid approach that allows developers to use SSG as a flow, but then again, have some parts of the application or the pages that you can say, okay, let's add revalidation here, allow the possibility to update those parts, only those parts, if and when the new data is present in the background. I have created some images. I have picked up some images from the really good online source where you can actually see how this works. On the client, so during the build phase with SSG, you can see that we have compilation, we have data fetching and page generation. And then on every single request from the client, you get the same HTML and CSS plus JS, of course. With server-side rendering, it's a bit different. Here we have on every single request, so the compilation is the only thing that's done during the build time, and here we have that on each request, you're again fetching the data, getting the data back, generating the HTML, and sending it to the client. And now with ISR, ISR allows you to have the same flow, the same SSG flow at the beginning, but then have parts of the pages left for revalidation. So when the client requests the page, if there is new data available for those parts of the pages that have the active revalidation, you're going to get updated data. Okay, let's move on. Data fetching. I'm not going to spend too many words since Faris did a great presentation today. The important thing here is overall to choose the right strategy. If you're going for the server-side fetching or the client-side fetching, it's really important because in the long run, it's going to make really high impact on your scalability. Having it on the server side, it's going to reduce the load on the client side. It's going to reduce the data transmission costs. But on the other hand, if you have it on the client side, you can reduce the server load and have server focus its own resources for other tasks. Next.js has a few options when it comes to data fetching. The first one that is used with SSG is get static props, which gets the data during the build time and generates HTML. The data that is fetched is embedded into the HTML and returned to the client. We have get server-side props, function that runs on each request to the server. It fetches the data and then passes it as a prop to the React component, renders the page on the server, and returns it back to the client. We have also some cool options like get static paths, where you can, when you're working with dynamic content, you have the option to set which of the paths are going to be static in your application. You, of course, have client-side data fetching with React hooks, where you can use Fetch API, Axios, or whatever you prefer. We have ISR there, which I already mentioned. Not going to go too deep into it, but there's an option to reload the data and have some parts of the pages. Like, for example, if you're creating an application as like a stock exchange or news portal, this is a really cool thing to have because you can only have one part of the application being revalidated and the data being updated, while the rest of it is static. And we, of course, have API routes, which I'm going to showcase a bit later when I'm going through how we actually did it and our example. Okay, now, state management. And the big question, is stateless an option? And here I specifically mean like global state. Is it possible to go without the global state? My advice is yes. You should try to keep your state local to your components wherever you can. In that way, you're going to remove the need for expensive and complex state updates, state reads, having like an additional global state management library on top of your code, huge centralized store, and other stuff. But, of course, there's not always an option to go without. And if you really need to use it, Next.js itself does not prescribe a specific state management library, but it is compatible with most of the most popular ones, like Redux, Mobix, TwoStand, and others. I will quickly show you what we did with Redux in our application and how that relation ended. Okay, but let's just like quickly go through the last design principle, which is performance. Many of the things that I already mentioned have a big impact on the performance. However, it is also worth mentioning code splitting, bundling, image dust optimization, lazy loading, CSS processing, and many other things. The goal here is to utilize every single tool that you have on your disposal to reach maximum in all of these, because at the beginning it may not seem, but afterwards it will have a really great impact on your performance and scalability. Next.js comes automatically with included Webpack and Babel, of course, before version 12, which means that the code compiling and code splitting is done automatically by the framework. Since version 12, they moved to TurboPack and SWC with the like Rust-based tools, which I know that many didn't like, but documentation claims that SWC is 17 times faster than Babel. And of course, there's like a set of predefined components that come with Next.js, like link, image, and many others. Image, for example, is cool because it automatically optimizes your images, allowing you to use modern formats like WebP. Okay, now let's go to the real world thing and the real world example. So in our application, we're currently using Pages router, but many of these things that I will talk about are also applicable for the app router. And just another note is that we did kind of like, let's say, good research before deciding what to do and what to use with our application, which does mean that it is going to work and it is going to be a best solution for every single architecture out there. Okay, the first one, middleware as a control station. Maybe not like such like a general approach, but when we started building the application, we started with Redux. And after 3 months, our centralized store grew so big that it was really hard to, like with the agile application where things are constantly changing, it was really hard to keep track, to update, it was wasting too much time. So we decided to completely remove it and to go, instead of centralized, to go with decentralized architecture. I'm going to show you some things that we use middleware for. The first example is we are checking, actually, like we're not doing this in API routes, we are doing this in middleware. We are checking if the user actually has token. This kind of allows us to handle the whole unauthenticated flow inside the middleware with these 4 lines of code. This also saves us of wrapping your components into like higher order components to check like if the authentication, if the token is there. We decided for this approach, and currently it is working for us. The second cool thing that we use middleware for is multi-language. The code was too big to put on one slide. Since we have like 3 different languages and we have 3 different, let's say, requirements when we were building the multi-language for the application. We had the user settings that was on the third-party identity provider. We had the actual language that was set by the user inside the browser. And we also had, if the user is logging in the first time, doesn't have any settings, it didn't change language, it needs to come from the browser in its headers. We are handling everything in like 20, 30 lines of code inside the middleware. One more thing is like all different, let's say, custom pages that you have in your application. For example, in our application, which is multi-tenant application, we are using tenants as a dynamic part of the route. And now, when somebody tries to access a tenant that doesn't exist, that is not automatically 404. Why? Because the route is still valid. You're accessing, dynamic part of the route is still there, the route is completely valid, and that means that you shouldn't be redirected to the 404 page, right? Here we did different things. So we basically are sending a request from the middleware. So we are intercepting a request. We are sending another request to ask if the specific tenant exists. And if the tenant exists, we are returning the user and saying, okay, you can proceed. If not, you're going to a specific not found tenant page. One more additional cool thing is that we also have the users that are logged in that can have accounts with multiple tenants. And from here, we can allow user to go directly to a custom page to log in with a different tenant if that is an option. Okay, now you can probably ask me, okay, but what if I don't want middleware to run on some parts of the pages? What, for example, if I have a public part of the application where I don't want to check for tokens, I don't want to check multi-language or other stuff, you here have a config that you can put inside the middleware where you basically specify on which pages your middleware is not going to run. Okay. The second thing is component modularity and reusability. When we were starting with the work here, we realized we are going to have a huge set of components, really a huge one. Like we went through all of the designs, and then we decided to use, after a bit of research, to use atomic design methodology that breaks design into small items, which again then form molecules and then organisms. Here you can see the structure that we have, and here you can see that we have actually like a huge list of components, and this is just molecules folder open. So atoms was on like 2-3 different slides. Why did we do this? Why was this really helpful to us? Because, like, first of all, it was easier UI testing, much easier UI testing, where you can test just those independent components and you can run your UI tests, and everything was like pretty fast to implement. The second thing was easier styling. Here, for example, we didn't use CSS modules. We used styled components with React Material UI, and it worked perfectly for us. Like, all the style files are inside these folders, so if you want to change something, you change it directly for that component, and it doesn't conflict with any other part of the CSS in the application. And the third thing, of course, easier typing, where you don't have to use global types or place types in like a store folder or like wherever it is. You can just like have it here, located and localized only for that specific component. The third thing was Next.js API routes. This part is a bit different than what we have right now in the app router, where you can still use API folder. However, API routes are replaced with route handlers, but that's for some other talk. Here is our current API structure, and here you can see that we have some complex APIs with dynamic paths. We have some simple ones, and I can show you now, I can show you now that it is here, Next.auth. We're using Next.auth for the authentication. At the start, when we created the project, since the backend was done in .NET, there was a logical solution to go with Identity Provider 4 and OIDC Client.js. I don't know if anybody here used those, but they pretty soon they went out of maintenance, and that kind of like highly popular solution for the auth was just like gone completely. We needed to switch, and we decided to go with the Next.auth because at that time we were a small team. It was like really heavy for us to develop our own custom solution or to go with some custom-based solution based on Passport.js. So this Next.auth introduced some limitations, but at the end it worked a great deal for us. I can show you now quickly. This is one of the testing requests that was like done a while ago, where we are testing only the public. This is just like the basic handler that is inside the API folder. So one API file endpoint. You can see that it's pretty simple, and that from here you can basically control whatever you want. Here, this one is simple. We didn't even check for the token. This is done on the public pages. And here we have a bit of a more complex one where we were actually checking also the validity of the token. So the important thing to note here that the actual checking if the token is present is done when you request for a page, and is done with middleware, which redirects you then to the no access page. But here we are checking the actual validity of the token. So we kind of relieved partly this part of the application by using the middleware. Then we don't have any global state. We have like a really huge application right now. And once we removed the Redux, we focused mostly on local state inside the components. And of course, usage of the following when that was not enough. Middleware, I already discussed. We use cookies. I know it's not that popular, but we use it like for really simple stuff, like user role in the front end in the browser, or having a language locale set there. We use URL params, of course, that are there for the, let's say you're editing a task, you're editing a user, you can pick up the ID from the params. You don't need to have any local state inside, like even and pass it down then as a props to other components. You can basically just use it from there. And of course, local page and local state for everything else. Now we come at the end at the aspect of security, where I can discuss a bit how we do this like process of authentication. So basically, we're using third identity party provider. We're using Keycloak in our application, which means that all the login and registration is not done inside the application. It is done on the Keycloak inside the tenant realm that is set up for the specific tenant. Once the user is logged in or registered, it is redirected back to the application with its own active access token and session to be used on the server side for accessing the other APIs that we have in .NET and get data directly from the database. This kind of enabled us to have really good security in terms of no access token, no sensitive session or user data is ever reaching a browser. Everything is done completely on server, and from the server, we basically control the whole application and control what is being served to the client. I'm going to mention here the thing that I already discussed with Next.js. One of the specific limitations that arrived, I don't know if anybody came to that issue. I know that it is still open on Next.js repo, like many of them. But there was a limitation in terms of Next.js using those internal variables, internal environment variables that basically Next.js also uses. And we had that there like a conflicting thing where we couldn't use subdomains, for example, for like assigning tenants. So we had to put that in the route. At the end, it wasn't a bad solution for us because it allowed us from middleware to check if the tenant exists and to manipulate with those tenants that we receive. But again, if you're like forced to do something and you don't have any other options, you don't feel that's like good with it. Okay, and I believe that's kind of it. I tried to fit 3 years of development into these 20-25 minutes of talk, so I hope you enjoyed it. If you have any questions, you can reach me on my networks, and yeah, or reach me here.